Okay, let's see. Let's see if we take the clamps off. And we seal that. That looks okay, and that's okay. So let's turn this around and glued that together. That looks fairly decent. And this part here, you remember we'd already done this part and this part. So now that is all glued together. I'll probably need a little filler in there maybe when I clean all this up. All right. So this is pretty solid now. The next step is I want to clean this with some Gojo. Gojo, not the abrasive kind, but the old kind. It was really hard to find. Got a little glue on that I need to clean up. That'd be okay. There. That's the original formula. It has no abrasives in it. I've looked at it on shelves, tried to find it in stores, can't find it. I end up ordering this online. Okay, we are in East Tennessee today, and it is gorgeous in the low 60s. A little bit of a breeze blowing, sun shining, and but we have a weather alert that says the humidity is super low, so it's a burn hazard. So we're looking at 20% humidity right now. So anyway, I thought I would see what we could do with this cabinet. I'm going to use this original Gojo. There is no grit in it or anything like that. It's just pure. Yeah, I'm sure I think it's a petroleum product. Let's see if we can read it. Ha ha. Good luck, right? Water, mineral oil, oleic acid, glycol, petroleum, sodium hydroxide, and a lot of other long names. So it's petroleum based, we'll call it. And what we're going to do is we're just going to take a little bit on a paper towel, and we're just going to apply it on the cabinet. I've seen other people do this, and we may be totally messing up. I don't know, but we'll see if we can clean. There's something on that right there. Not quite sure what that is, but getting a little bit of the crud off of it. But let me go over this. All I'm going to do is go over it and then rub it in and then wipe it off, and we'll see what it looks like. Okay, ladies and gentlemen, here's the cabinet that I have, I'll say, restored somewhat with Gojo hand cleaner. I've seen it done, and it just brightens and cleans the finish. And I cleaned all this up. There's some overspray from years past, and I'm not going to try to take that off. But as you can see, the inlay really looks good. The finish looks brighter. It's not perfect, but it's more time. You know, if I could strip it all off and redo it, but then it wouldn't look like an old radio, and I want to keep it intact. So there it is. That's as you can see on top. It still shows its age. and that's what I want. I want it clean, showing its age, and but I want it to sound good too. So, or at least work. So there it is, a Gojo refinish. Let's recap their proposed circuit that we're going to configure this radio in to get the heater voltages, and use this capacitor to drop the resistance in place of the resistive line cord. And so we'll start out with a polarized plug that we've talked about earlier. I'm going to use an antique cable and a polarized plug. The neutral side of it will come down and go straight to chassis ground. Then we'll come and we will run it through about a 1 amp resistor, 1 amp fuse, excuse me, and then through the switch, the on-off switch. Now from this point, we will take the 120 volts AC, and we'll take it to the plates of the rectifier tube, the 25Z5, to generate our B+. We may have to look and see if we need to drop this. So we really don't have any specs on it. And as long as I'm wanting to say that we may end up putting an 80 ohm resistor, because there was an 80 ohm resistor in that circuit at one time. So we'll have to look at that. But right now what I want to do is I want to wire this part of it up and get the voltage from here to here correct, because this is, we're going to have to protect our tubes and of course our light bulbs also, but we want to make sure that this capacitor is going to drop enough voltage. Well, from this point here we go down to the one side of the capacitor. Then from here we're going to have to build us a circuit to take the two bulbs, the dial lamps that are in series, and we're going to put it in parallel with a 50 ohm resistor. That's in case if one of the bulbs burn out, the resistor will carry the current and keep the radio playing. And then from here we'll go through, this is the way it's wired on the chassis already, and then it'll end up going to ground here. So this is how we're going to work towards wiring it up initially. Then from here we'll work with the B+ later, but I want to make sure that this capacitor is going to drop the voltage correctly here to protect this part of the circuit. Also, I've already mounted the 8 microfarad capacitor under the chassis. That should be okay. I think there's plenty of room there. No heat, shouldn't be no problem. But if you'll recall, one of my subscribers suggested that at first I was going to leave the circuit breaking the neutral side, but that doesn't make any sense. He brought it to my attention and it doesn't make any sense. So I want to break the positive side of it. But if you'll notice, here's the on-off switch for the radio, and you'll see that this side of it is to ground. So the initial circuit had, well, of course it was a 50-50 chance with the unpolarized plug that this could have been hot going to ground or neutral going to ground. But in this case we want it to switch the positive side. So as you can see, the switch is also tied to the center of the potentiometer. So we're going to have to take this wire off of here and bring it straight from here down to chassis ground, and then we'll use this to break our circuit, our hot circuit. And then we will and I'm probably going to replace this whole wire to ground away from that. I started looking at the circuit in the radio when I started trying to wire that, and remember I was going to try to put the bulbs and the resistor up here But the way it was wired originally is the bulbs and the resistor was on the tail end of this chain to ground. So I drew it that way and put that in the circuit. And we're still going to do the plug, we're going to do the fuse and the switch. We tied the capacitor straight to the switch. Now what I'm going to do is I'm going to use my variac. I haven't done this part of it yet. I'm going to put the variac here and the ground, and then we're going to bring the voltage up, and I'm going to put a meter across here and here to make sure that we don't exceed the voltages. 25 is 50 plus 12.6, you know, it's 62.6 or so. So you know, if we're between, well, we'll just look and see what it is. I just don't want to, and I'll ramp this up, and I'll also put another meter on the AC to make sure we get to our line voltage of 120 volts, and we will check this, and then we will also check this across here. This should be approximately 12 volts across here, so we'll check that also. So we'll see how it works. I plugged the tubes in. Let's see, let me zoom this in for you. As you can see here, I went ahead and put the 8 microfarad capacitor in here. Right here is the 50 ohm resistor that goes across the lamps. I tied one side of it to ground. I put a terminal strip here to do that with. And so what I'm going to do is I'm just going to alligator clip those lamps between here and here to complete the circuit, and we'll have them laying over there instead of putting them in. And then we will I went ahead and put the capacitor, wired the capacitor in on the switch. So all I got to do is put the AC on either there or there just to test it. I've got the tubes in line, so let's put it together and make a little smoke maybe. I went to do some resistance checks on my tube chain, my heater chain, and I found out that the 43 tube had to open a filament. So I had to wait until I got a another tube. So we're going to test this, and then we're going to put some voltage to it. Now I want to warn everybody that if you do not know what you're doing, the potential to kill you is there. Now right now it's not connected. I'm just doing a resistance check, but when we get the power hooked up to it, there is potential to kill you. So anyway, one of the things I found out is the on-off switch is open or dirty. We're going to have to clean it up, try to make that work. And besides, even if we went through it, we would be going through the capacitor, and that's not going to work. So we're just wanting to do the heater chain right now. So if we go across this rectifier tube, we're looking at 12.5 ohms. Now, one of the things about it, these are cold resistances. Once they warm up, if you will power them up and warm them up and then pull them out real quick and check them, you will see the resistance changes quite a bit. It goes higher. And so and then you can watch it drop. That's just an experiment if you want to do it. So we'll follow over to the next tube, which will be the output tube. And so now it's also a 25 volt drop, which has almost doubled it. So now we're 23 ohms. We'll go over to our next one, and let's see. This is the 6.3. So now we're at 26, almost 27 ohms, and then that goes over to the next tube and up to here, and now we're at 30. And if we go to ground, we will capture the lamps and that resistor. It's in parallel, and so now we are setting right at 40 ohms or so. Now that's cold resistance, so you know, it will change when we put power to it. So right now I'm setting at almost 123 volts on the line. So I'm going to hook everything up, and then we're going to bring it up, and then we're going to check between the tubes filaments, and we want to bring it up to 123 volts and make sure that we don't have 63, because remember we added all this up. 25, 25 is 50, and 12.6, 62. So I'm looking, if we can get between 58 and 63, I'll be extremely happy. And just for documentation, this is the resistance across the bulbs and the resistor in parallel with each other. Okay, I've run the line voltage up to 23 on my variac. That's going to be more than normal. Most of the time it's going to be 120 or below, and the heaters across the tubes are setting at 63.5. What we calculate at 62.6. So less than 1 volt, and typically the line voltage should be less than this. It's extremely high today. The bulbs are working over here. You may see those, and I'm drawing right at 250 milliamps, which the tubes are rated at 0.3. So I could add some more capacitance and drop that a little bit more, but since this is on the high side, I'm gonna call it good. And then from here, we're going to be able to go ahead and rebuild the radio, put more components in it, and everything like that, and hopefully bring this thing back to life. I know it's been a long time, and I apologize for that, and but I've just gotten busy and doing some other stuff, and I've got another one in the works that you probably get to see some parts of it here shortly. Son-in-law has picked up a console radio, 1937, with a magic eye tube, and he wants it restored, and I'm working on it right now. So anyway, that's going to be it for this part. In the next one, we'll start replacing the components, and like I said, this has the potential of killing you. So don't do this unless you know what you're doing. So, from Larry, from the hills of Tennessee, thanks for watching. Okay, just for grins and giggles, I run the voltage down to 120, and you see we're setting at 61.3. So that's what we calculated it to be, roughly, for 120 volts. And so I think this has been a success, and I think this is going to work out just fine. Okay, this is the voltage across the light bulbs. You know, we'd talked about 12 volts. So with the resistor and the bulbs in parallel, it's only dropping 8 volts, which should make the lamps last a little bit longer. So that's okay. It's acceptable. The bulbs are not totally bright, but they'll light the dial light up really well, I think.